Welcome back, everyone. We have all heard about dependency inversion principle, but let's see what exactly is. Let's start with the definition. So this principle says that high-level modules should not depend on low-level modules. Both should depend on abstractions. And abstractions should not depend on details, but details should depend on abstractions. This may seem an abstract definition, so let's start by asking ourselves, what is a high-level module and a low-level module and an abstraction? So let's take a closer look. High-level modules are the part of your source code that provides added value. These modules are written to respond to problems and use cases. They're generally a little abstract and represent the business domain, or we might call it business logic, to represent the application's functionalities. And finally, these high-level modules tell us what the application should do, but not how it should be done. In contrast, low-level modules represents the implementation details required to run the business. High-level modules are abstract, and at some point, a concrete implementation of functionality is required to meet business needs. So they represent how the application behaves with respect to business logic. So we said high-level modules tell us what the application should do, while low-level modules tell us how it should be done. Let's take some examples of low-level modules like logging, especially console logging or a log file, or data access or network communication through network protocols, let's say. The idea is that these are very concrete in nature. So high-level modules generally work well with low-level modules to meet customer needs. So for example, let's imagine we have an application that offers user management functionality. So the high-level module will provide the functionality to meet the customer needs. And for this module to work effectively, for example, it depends on a certain low-level module, such as data access module to persist information and a security module to guarantee user authentication. Note that low-level modules are very concrete. For example, for data access, we use SQL requests. For security, we use OAuth technology, and so on. And also note that the terms high-level and low-level modules are relative. For example, we can have a certain tree structure, and starting from the top down, we go from the most abstract to the most concrete. So a component can be considered high-level in relation to a more concrete component, but also could be considered a low-level in relation to a more abstract module. So what's an abstraction then? So it's something that isn't concrete. So as a developer, it's something you can't instantiate. In Java, we model them using interfaces and abstract classes, for example. So having clarified these terms, let's take a look at the big picture. Generally speaking, when we depend on details or implementations, our components propose this particular relationship. We have a high-level component that depends directly on a low-level component. And of course, by doing so, we violate the principle that both must depend on abstractions. So let's add an abstraction here so that our high-level component no longer depends directly on the low-level component, but rather on an abstraction. And so abstraction B must not depend on details. When there is a dependency based on details or implementation, that's when we have a high-level component that depends on a low-level component. On the other hand, when there is a dependency on abstractions, the direction of the dependency is reversed, as shown by the arrows in this diagram. I hope you enjoyed this video. Don't forget to hit the bell for more interesting content, and thanks for watching.